Cool. Yeah, nice to meet you.
All right, hey guys, thanks for sticking around. Thanks to the Boulder Ruby organizers for having me give, I think this is actually my first time ever giving a talk, like a legit talk. So I've been coming for a couple years and I'm super excited to talk about something I'm really passionate about. My name is Joel. I live just south of Boulder. I'm an engineer at GitHub. We'll talk more about that later. So today I want to talk about something that is really near and dear to me, which is learning new languages and frameworks. And I like doing this because it gives me a different way of thinking about the world. And this was especially true with me when I learned React. React changed the way I looked at Rails. So today I'm going to talk about that change in perspective. So we're going to do this through an exercise. We're going to take an actual template from the GitHub app that has proven really hard to test. It's impossible to measure with code coverage tools, overfetches on active record objects, and fails what I would consider basic Ruby code standards. And we're going to refactor into Ruby classes that are tested efficiently in isolation, are audited using code coverage tools, only receive the data they need, and follow the code quality standards of the Ruby language. And perhaps most importantly, we're going to make things 100 times faster. So let's talk about views. So what even is a view? So I think it's helpful for us to have a definition if we're going to talk about them. So for the sake of this conversation, let's just call a view something that turns data into HTML. What does this look like in Rails over the years? The reality is that things haven't really changed much. Rails is still using embedded Ruby templates that were shipped way back in 2004. You know, we did get turbo links in Rails 4, which gave us partial page reloads, and Rails 5 gave us API mode. But I think it's really telling that when API mode shipped, DHH had something always very careful to say about it, which is that Rails is not only a great choice when you want to build a full stack application that uses server-side rendering of HTML templates, but also a great companion for the new crop of client-side JavaScript or native applications that just needs the backend to speak JSON. Oh. So the reality is that the history of the view layer in Rails is one of everyone moving away from it. I think it's telling that the next release of Rails included Yarn and Webpacker, which basically just like cemented that fact. So what does the view layer look like at GitHub? I asked Marty what he thought this would be tonight, and he guessed incorrectly. The reality is that we are still using ERB. So why isn't GitHub a single-page app like literally every other app we're all in this room probably working on today? The answer is progressive enhancement. So GitHub is built to be usable without JavaScript. Try turning it off sometime. It's easy to forget about users in developing countries, right? So like, you know, we may all have these super powerful MacBook Pros, but for a lot of the people that are joining GitHub today, they're using netbooks, they're using Chromebooks, they're using tablets, and those kind of devices buckle under heavy JavaScript. This also allows us to provide graceful fallback support for legacy browsers instead of just shutting them out entirely. What does that look like? So we do what we call tiered JavaScript. This is the actual source from our application HTML ERB file. Basically, we have a couple different levels. So for fully supported browsers, you can kind of read through this logic. They get the normal bundles. They get frameworks and GitHub. We have a second tier of browsers. They get polyfills, the compatibility line. And then for browsers we don't support, we have a much smaller set of polyfills that fill in a few gaps in the application. What's nice about this is that when we've decided we don't want to support a browser, instead of just shutting it off from the world, we kind of move it through these tiers as we upgrade our JavaScript libraries. So what does that mean? It means that we're doing all of our rendering on the server. Take, for example, posting a new issue. So what happens when you post a new issue on a new issue comment on GitHub? You click the comment button, JavaScript intercepts the click on the button, triggers an AJAX request. That AJAX request, in addition to creating the comment, also returns 3 DOM nodes. You can see there in the inspector in the top right. So we take those 3 DOM nodes and put them back into the view. This is kind of like TurboLinks. It's using a library called PJAX, which is kind of like TurboLinks Plus, TurboLinks Junior, I don't know.
A little older than TurboLinks.
It's like it predates TurboLinks by about a year. It's also, I think it was interesting to find out that TurboLinks is actually 3 years younger than GitHub. I have yet to figure out what we were doing for those 3 years. Came out in like 2010, and GitHub is older than that. And if JavaScript is turned off, since we aren't intercepting the click on the button, regular request goes to the server, comment gets posted. No one even knows they're not using JavaScript. So let's talk about building views at GitHub. So what I do at GitHub is I run a project called Papercuts. And what we do is we make GitHub better through incorporating community feedback. So we're recently refined GitHub and incorporating a lot of the features into GitHub. We recently shipped this feature called sticky headers. Yeah?
Can I ask questions? Do you want me to wait?
Yeah, you can ask. Yeah.
When you go back to you have to go back to the browser screen.
Yeah.
I was curious, obviously you guys probably keep a really close eye on who is using GitHub, right? Like
Yep.
which browsers and whatnot. So could you share any of those numbers on like the different tiers or like magnitudes?
The real answer to that question is that we're the 10th most trafficked website in the United States, period, not just amongst engineers, but period, which means that even if it's a small percentage, it's still a lot of people. Like, you could imagine a situation where like 0.1% is 100,000 people.
Sure.
That kind of scale. So like the answer is that there actually is no population small enough in most of our cases, unless you're using some like esoteric text-only mode on your old Linux box, right? Yep. So if you want our links usage statistics, there's someone I can ask. We'll put it in the report next year. I'm sure they'll cover really well. Yeah, I think that the reality is that it depends on the market, from what I've seen. So, like, you might see in the United States, we've seen this across the board, where, like, generally the wealthier the country, the more powerful the computers people are using, right? So, like, the reality is that the United States market is pretty saturated. So if you're doing growth in all of these new developing countries, you're more likely to run into people who are using underpowered devices that may be more out of date, that can't support the new technologies we all like to use.
Quick question.
Yeah.
Tagging on. Has Chrome OS improved that for you? Because now you've got these relatively low-powered laptops that are getting good updates consistently.
I think that in some areas it has, yeah. I think it's probably more improved access to technology than it has improved the level of it. So like you see like kids getting into it earlier.
And what's the oldest version of IE that you guys support?
11.
Right.
Wow. Okay.
Yeah.
So you stopped serving JavaScript?
We stopped serving JavaScript to them, but we still make the
At
app.
11?
Yeah, at 11. No, sorry, 11 is the last we support. So 11, below 11, yeah. Okay. So, but because the app works without it, yeah, you're going to notice that like a lot of the flourishes don't work. But if you need to get in there and do it, say you got a product manager at an old enterprise company and they're using IE9, they can still use GitHub. A lot of our business is in the enterprise. That's an important lesson with the way we've architected things. All right, anyways, on to today. So this is the issue badge, and this is what we're going to talk about today. It's like literally the smallest piece of the GitHub UI. It's used to display the status of issues of PRs. So it's important to know that in our data model, all PRs are issues, but not all issues are PRs. So a PR is actually a layer that sits on top of an issue that maps to the diff and everything that comes with it. Just a little aside. So this is the actual source of issuebadge.html.erb, minus a few things that haven't been shipped yet. So this thing does a couple things. It renders an icon, it renders a label, it somehow maps to a color, and it basically takes the state of the issue or the PR and presents it to the user. So I, of course, came across this template when I was looking to build that sticky header feature I just showed. And we just shipped it last Friday. Thank God. I was worried that it wouldn't ship in time for this talk. It was going to make things really awkward. Where I would have presented you all with NDAs before I gave the talk. Yes, we would NDA you over sticky header. But what was interesting about this is that I was working on this, and I was looking for test coverage, and I found one test, one assertion. And it was one happy path in a controller test buried somewhere. Literally, I deleted this whole file, and one test failed. That didn't seem right.
Well, separate question.
Yeah.
How long does a test suite take to run it, Caleb?
It's measured in more hours. More hours. If you ran it linearly on one, like non-parallel, more hours than you can count with your hands, but not with your hands and your feet.
And parallelized? As many
6
hours.
minutes.
Really?
Yeah.
Wow, interesting.
Kubernetes.
And you'll do a talk about the process of how you got from how you got to be able to parallelize all those tests at some point.
When that person is flown in, we have a
That's
Boulder.
it.
I don't know if you guys knew, but we have a Boulder office. So that's actually a good way for us to think about talks. Is if I ever know any cool people flying in, I will definitely like. Eileen is a Rails core contributor. Aaron is a Rails and Ruby, and they come in occasionally. Eileen was here a month ago. We should have had her talk. You know, so I'll think about that more in the future.
Definitely bump you.
Oh, totally. The fun part about tonight is I get to take this recording and I get to send it to Eileen and ask her how full of shit I am.
Or how likely she wants to come here.
Yeah. We'll see.
Please come, Eileen.
So let's talk about what GitHub Scale looks like. I just ran these the other day. These probably have already gone up. But things aren't simple here. We're a 10-year-old Rails monolith. We've gone through like every Rails upgrade, over 500 models, and that doesn't include 1,500 concern files within our models folder. So we're looking at 2,000 files in our models folder alone.
Okay, so but you're a 10-year-old Rails app running Rails 5?
Yep.
That's fucking
5.2. And in fact, I think that we're actually running what I would consider Rails 6 because we have features in our Rails that aren't even in Rails yet.
I think I need some more whiskey to toast.
Yeah.
What version is New Relic running?
I
I kind of want to know as a customer.
Yeah. Yeah.
142.
Cheers to that. And you want to know something really even crazier that I can tell you guys now because this is public? We were running 3.2 in February.
Whoa.
Yeah.
So you went from 3.2 since February?
Yep. There are a lot of very smart, hardworking people working on that.
Can we
So
get one of them to do a presentation?
they're hard guns. So this doesn't include the API either.
Wow.
Yeah. So how might you think this would affect our approach to testing the view layer? Oh man. So the reality is that in our test suite, to run a single controller test, this is literally measuring just inside the test block, no setup, it takes 6 seconds for one controller test. Why do you think there's only one controller test for our view? So the reality is that if you write 10 suites, it's going to take you a minute to get feedback. So you know how when you're at a sporting event and they ask you to have a minute of silence? Imagine doing that every time you make a change to your code base. You get the point. So so why isn't testing our views thoroughly a more common practice? I believe this is a symptom of several flaws in the way Rails approaches the view layer. The number one being the lack of unit testing. So unit testing views isn't really common practice. I didn't even know you could do it until I started researching this talk. And I've never actually seen it done in any Rails code base. So the reality is that partials like these end up being tested for each of the views they're included in, which basically just means you have duplication of tests across all of your consumers of your partial, which kind of cheapens the point of having a partial in the first place.
Nice.
Another problem is measuring code coverage. Simple cov and coveralls, the way they work fundamentally is incompatible with the way templating languages execute Ruby, which means that, combined with the testing friction, this puts our views in a blind spot because we don't have a great way of testing them, and we have no way of measuring how well we even have. So another weakness that I see in views is the lack of a method signature, just something so basic that we expect out of every Ruby class. Views don't expose the values they're expected to receive. So let's look at our example again. What data does this view need to render? Does it need a poll object? Does it need an issue? What happens if I pass in both of them? What happens if I don't pass in either of them? Imagine if you didn't know the relationship in between the two models, how much even harder this would be to understand. So what if we thought about this in the view model architecture? So this seems a little better, right? I'm going to take a few code shortcuts in this presentation for the sake of keeping things moving. But it might look something like this. And this is something we do at GitHub occasionally. But we found a lot of problems with this approach. The number one thing being that you end up with two files that are basically interlocked. You can't use one without the other, which just seems wrong. And the other thing is that what you end up doing is you do this because you feel bad not being able to test the view properly. So you test the shit out of the view model, and it makes you feel like you're testing the view, but you're not. Another problem comes from using active record, which is overfetching data. So for pull and issue in this example, what attributes do we actually need from each of them? So if these are active record objects, we were fetching their entire set of attributes just to render this view, when we may only need one or two. This makes our requests unnecessarily slow. And I think finally, the reality is that our views regularly fail even the most basic standards of code quality we expect out of Ruby classes. It's kind of weird. So let's go back to our example. For a second, let's imagine that this is a Ruby class. And let's put it up for code review. Can anyone think of what kind of comments you might leave if this was a Ruby class?
Sandy would not like it.
Sandy wouldn't like anything I have to say today. Okay, so I can think of a couple.
The markup's all basically the same markup.
Yep.
Thought times.
Yep, so there's some repetition. So one would be, where's octocon defined? We've got this helper method here. Who knows where it comes from? Where does this class attribute value come from? It kind of feels like a magic string. That's a really common code review comment. Where are these pull and issue objects coming from? There's no method signature. And what should we do when neither pull nor issue is passed? Kind of talking about what we saw earlier. So to recap, Rails views are difficult to test, and which puts our views in a bit of a blind spot in our applications. They can't be measured with code coverage tooling. They have implicit arguments. They don't really improve much with the use of view models. And they make it easy to overfetch data. And most importantly of all, they fail basic Ruby code quality standards. So the reality is that the existing Rails view layer is a second-class citizen these days. So with all these shortcomings, it probably isn't much of a surprise that a new way of building views has taken hold in the Rails community. React. So let's talk about what concepts React has made popular. A small disclaimer here, it's been about a year since I've actually worked with React because we don't use any JavaScript frameworks at GitHub. We just got rid of jQuery and have replaced it with vanilla JavaScript. I used it a lot at Galvanize though. So things change a lot. These examples are probably all wrong, but I hope you get the gist of it. So the most important concept in React is components. And components are simple, small, and reusable view renderers. Here's an example of what our issue badge might look like if it was a React component. They're pretty simple. They expose a render function that returns HTML, kind of like our definition of a view. Notice that this kind of looks like we had in our view model example, but in a single file. But then things get a little different. React has type checking, or at least it did, and I'll talk about that in a second. So there's a prop types library that was recently pulled out of React, but is kind of like still part of the standard toolchain, and it gives us runtime type checking for our React components. So this allows us to express some expectations about the data we receive. So the example here is we have an issue object. We expect to always receive it. That's the is required. It has a Boolean attribute of is closed, which we also expect to always get. And then we have a pull object that, since it doesn't have is required on it, can sometimes be there. But if it is, it's always going to have those two Boolean attributes. Gives us a pretty clean way to describe exactly what we're expecting to come into our function. What's nice about this is that we can then write code without checking for the presence of the object. So for example, in this mocked up icon function, we can just call right into issue is closed because we know, based on the prop types enforcement, that it's always going to be there. Another advantage of React is how it encourages writing components as pure functions. By passing data into views instead of passing in rich objects like we do in Rails, React encourages us to write functions without side effects. So in reality, this is not something that's unique to React. Basically, any architecture that forces you to split the front end from your back end is going to lead you along this path. But one of the really cool things about React is the way it changes how we test our views. It makes it really easy to test them in isolation. So here's an example test that asserts against the output of our component. What's great is that this test runs without touching any other layers above the view, let alone touching a browser, which means it is stupid fast. This test you could basically consider free from a computational cost standpoint, at least in 2019. And perhaps the craziest thing that React has brought to the world is CSS and JavaScript. And quite literally, this means writing CSS right next to your component file, which is like really weird. But under the hood, a lot of the CSS and JS libraries you can use basically give you a unique class name and then assign it to the component. And this is probably one of the more aggressive things I've seen in a while in terms of like changes in paradigms around web development, but it does have some interesting benefits. So only the CSS needed to render what is on the page is loaded at a given time. There are no class names or selectors in the code you write. And since CSS is coupled to the component, you don't have to go across multiple files to know what CSS is going to affect the view you're working on. This also means that when you delete a component, you're deleting all of its associated CSS in one shot, which is, you can imagine when you have 3,700 view files, how much of a problem that would be if you don't have this kind of pattern.
Turns out that cascading part sucked.
Yeah, exactly.
I've been starting to brainstorm like different abstractions around CSS. That's a different talk though.
Is it just CS?
It's it's actually using Unity for websites. No, I'm just kidding. Just throw it all. Just throw the whole stack out the window.
Yeah, that's right.
So React has components. It has types. It has functional purity. It has lightweight testing and isolation, and has a new way of thinking about CSS. And while I really wish we could use React at GitHub, it's not really compatible with our progressive enhancement approach. But there are plenty of ways we can use these lessons to improve the way we reason about the Rails view layer. So let's see if we can use some of these techniques from React and perhaps address some of those code review comments. Components. So what might it look like to have view components in Rails? Well, first of all, our views could be objects, like everything else in Ruby. Probably a good place to start. So let's do some TDD. So first, let's require that an issue is always passed to our component. Pretty easy to express in a test. Pretty easy to express in a class interface. Since our view is now an object, it can have one. So that crosses off the implicit arguments problem. So let's start to work our way towards parity with that existing view file. And let's start with a test for a merged pull request. This is literally the controller test we had before rewritten as a test of this new component thing. So in order to get the test to pass, I had to add our octacons helper explicitly because it wasn't included by default. This addresses the invisible dependency concern that came up during the code review. So next I had a test for the rest of the 5 cases. You can kind of imagine they look like this. I wanted you to be able to read them so they're not all on the screen. And so here's my first version that got the test to pass. But notice that it basically just mimics the view wrapped inside a class. It's already better, but we can do a lot better than that. It's worth noting that at this point, I was able to run the component through simple cov and get a score of 100%, which means that for the first time ever working on a view on this code base, I could refactor with confidence. So let's go through a couple of refactors. So the first refactor is pretty naive. It basically just dries up the repeated kind of like here doc HTML syntax. But what about those magic strings? So there are at least 3 sets of magic strings in our component here. So we've got our CSS class names, we've got our octacon name, and we have our label text. The CSS class names come from our design system, which we call primer. And expressing this fact in a Ruby class makes it really clear what our component is coupled to. The same goes for the icons. For the labels, it turns out that the issue and pull request models have methods that return these values, so we can just use them inline. And now we've ended up with a giant conditional statement. So let's see about refactoring that. So that's getting a little simpler. We've got a separate method that returns each of the values we're looking for. But something looks a little off about that label method to me. And maybe it's a sign of a bigger issue of our component here. The reality is that the consumers of this view already know whether they are passing us a PR in an issue or just an issue. So what good are we doing handling this logic in our class? Let's pull it out. So let's make our label a required argument. Now we only need a single assertion to make sure it's rendered, and then we can remove that same assertion from all of our state-specific tests. So what about types? In our current implementation, we have 3 arguments: issue, label, and pull. And while these names might imply a certain class of object would be provided, Ruby doesn't really give us much help here when it comes to giving us any sort of confidence about what's being passed in. The reality is that we could pass in anything for these values, and all that matters is that they respond to the methods we're calling on them. The label is easy to reason about. It's just injected as is into the view as HTML. But it's not so simple for those pull and issue objects. So if we look at this conditional again, for our pull object, we ask it whether it's merged. If not, we ask it if it's closed. And for our issue object, we just ask whether it's closed or not. That kind of sounds like what we had in prop types. So one implementation of this.
Sorry.
Yeah.
Could you just slowly flip between that and the previous slide for a second?
Sure.
Because I think that'll help people maybe catch that logic similarity there.
Yeah, so right here, so we have our pull object. And this is the most complex conditional in this class. There's simpler ones. But we're asking two questions of it. Closed or merged? And for issue, we just ask whether it's closed or not. And this signature mimics exactly what we had in our React example. So this is what, I'm not a computer scientist, but generally is called a contract. And there's a library that allows you to write contracts in Ruby called contracts.ruby. And this is generally what it would look like. But this would require us breaking off from the Ruby standard library. And I'm going to be completely honest with you. I wrote this whole presentation inside the GitHub code base with passing tests the whole time. So I could not use this because getting it into our bundle was just not going to happen. So let's hold off on this and see if it's still necessary later. So what about functional purity? One tool we use at GitHub to guard against unintentionally running queries is this kind of like assert no queries test helper. So you might imagine that we use it to wrap code. We want to make sure it doesn't result in queries to the database, like this. Yeah. We use a similar one to assert that no jobs are rendered. Obviously, probably not something you need to really be concerned about with your views, but I've seen things, guys. You could imagine dropping this in a base class somewhere and just see if you catch anything sometime. Could be interesting. So if we go back to the two conditional trees in our component, it seems to me that we might actually have two components here, not one. There's a lot of switching here around whether we're dealing with a pull request or not. So let's try making a separate pull request component and see what happens. With separate components, our conditionals certainly get a lot simpler. There's some duplication here. Both classes are still building the same element from our design system. So why don't we refactor that out? So here's a new primer badge component implemented as part of our design system. It no longer has any coupling to our apps domain at all. You could imagine this being provided by the design system library itself. We actually have a primer gem. It could implement this class and we could use it in our app. So let's refactor our issue and pull request badges to use our new primer badge. But there's still more for us to do. So let's think about functional purity again. So we were mainly concerned with our component unintentionally querying the database. I think that's like, I asked you guys actually on the Slack channel one day, what is your number one fear with your views? And someone said, unnecessary database queries. So this is like literally a capturing of that in a slide. But what if we could avoid passing in active record objects at all? This would basically eliminate that risk. So if we look back at our issue badge, it looks like we're only depending on a single Boolean attribute on issue. So what are we doing passing the whole thing in? Let's just pass in that attribute. Our tests get a lot simpler. Notice we're just passing in a Boolean. The implementation of our component knows nothing about issue except whether it's closed. So let's look at the pull request badge. It needs to know a little bit more about pull requests, but not much. In this case, it makes sense to switch on an existing state value instead of passing in the entire pull request. And for the sake of consistency, we can implement the issue badge the same way. And finally, we can remove that label argument altogether because it turns out it was just a titleized version of state. So now we end up with these classes that are pretty simple. What about CSS and Ruby though? Don't laugh too much. So let's have a quick look back at our JavaScript example. It incorporates kind of two kinds of CSS. Kind of like base component styles, but also like status-specific styles. So let's tackle the latter first. So we can start by using a color argument directly as an inline style. As an aside, we could also have our design system implement Ruby constants that map to those colors. And then we can update our components to pass in those color values. So this inline approach makes sense for like the dynamic things on the badge, but what about the rest of the styles? Doing this in Ruby could be tricky. The way these libraries generally work in JavaScript is you're kind of registering your CSS to like a global collector that then dumps it on the page once all the components have been rendered. It actually literally puts the CSS in after you have rendered your components, which is kind of backwards if you think about it. So if we were to do this in Ruby, we would need to somehow like extract the CSS at some step in the process, whether you probably wouldn't want to do it at request time, certainly, probably at build time or with some tool, along the way. But the reality is that this component is already in our views. And if we just call the component directly, we've already isolated the CSS because our views don't have it anymore. So I view this step as largely unnecessary now that I've looked at it critically in the Rails context.
Can you say that again?
Okay. Was that a little?
I'm not fully following. I'm
Sure.
Catching up to you.
Sure. So one of the biggest issues we run into with our style system is that it changes and we make new releases of it, and we might actually change the interface on it. It's like any other program. It literally has like CSS classes mapped to specific pieces of the component library. And if in that situation, to do an upgrade, we literally have to bump the gem locally, change all the class names to match, and then test it, click test it through. If, for example, we had a component that just wrapped that class name, we'd only ever re-render the component, and we'd contain that change just to our wrapping of the style library. It's very similar to the way you might use an adapter pattern for like an external API, like a Stripe, like a payment adapter. Also, as an aside, that would allow you to swap in different component systems, which could also be a nice way to use this abstraction. Does that make sense? Think of, in some, adapter patterns, but for styles. But to be honest, I'm really happy with how we ended up with these inline styles. And like I said, I don't really see a huge benefit to inlining the rest of it. So let's come back to types. Based on what we've come up with, they don't really look so necessary anymore. And let me make an argument for this. By using constants for our expected values, we make it easy for the consumers of our components to pass in the value we expect. So for example, these states in our system are symbols. If we built this without these constants and someone passed in the same state as a string, we would have to either coerce the string or do some sort of monkeying to make sure that we accepted different forms of that state. But you can imagine a consumer of this component would literally just use that same constant, and it gives you a coupling in between the calling of the component and actually running it. But the coolest part is let's talk about performance. So like I said earlier, controller tests in our suite literally take 6 seconds to load a page and assert against its contents, which is the most basic way at this point that we have of testing views. So what about these new unit tests? I couldn't get them to run faster than 50 milliseconds. And these measurements are independent of any setup routines, which keep in mind if you're thinking of these examples, in the traditional controller world, we'd have to touch the database. So I can tell you from some basic measurements I took, these controller tests had another 2 to 3 seconds of setup just getting the database in the right state. Now that's spread across multiple tests generally, so I didn't really want to include it in these measurements. But know that the unit tests literally have no setup as they were written for this presentation. They were 120 times faster than the equivalent controller test. So what does that really look like though? It means that all of our tests ran in half a second instead of 60 seconds if they were controller tests. So to recap, we started with this view. It was hard to test efficiently. It was impossible to measure with code coverage tools. It overfetched active record objects, and it failed basic Ruby code standards. And we ended up with this, a set of Ruby objects that I think maybe the coolest takeaway is that it maps our domain models into our design system. It also opened up efficient tests that were isolated. It allowed us to audit using code coverage tools. and allowed us to only pass in the data we needed to render our views. And I think perhaps most importantly to me is that it's actually Ruby, and it follows the code standards of the Ruby programming language. And the reality is that this gives us higher confidence about our views, and perhaps most importantly, makes it feel like they're a first-class citizen in Rails. Thanks.